Hi everybody, this is the lesson 3 video. We're mostly just going to talk about vocab for this lesson, and then we'll do stuff with numbers in the next lesson. So to start off, let's talk about these 3 vocab words: radius, chord, and diameter. Now I'm sure you know what the radius of a circle is and the diameter, but we haven't really talked about a chord before. So I'm going to give you the definitions for all of these. To start, the radius is the distance from the center to any point on the circle. Okay, so you can have a radius from the center to any point on the circle. Okay, it could be anywhere you want. It's always the distance from the middle to the outside. And for a circle, all of these radii, the plural of radius is radii, they will all be the same length. Okay, they have the same distance from the center to any point on the circle, because that's what a circle is. It's all of the points that are a certain distance away from the center point. A chord is a little bit different because a chord doesn't connect the center to an outside point. It connects two outside points together. So a chord can take any two random points that you've got on the circle and connects them. So the diameter is a type of chord. Okay? It has the same starting definition. It connects 2 points on the outside of the circle, but it must go through the center point. So a diameter is a type of chord that goes through the middle. So that means that since it goes through the middle, each half of the diameter is going to be equal to the radius. And you guys knew that already. You know that if you do 2 times the radius, it will equal the diameter, or the diameter divided by 2 equals the radius. You guys have done those equations for a long time now. We don't have any equations for chords just yet, but we will talk about those later on in this unit. So again, the last piece of information here is that the diameter is twice the length of the radius. So if we were to look at this down here, there's a couple things that are important. First thing, the diameter is going to be CD. We know it's CD because C and D are both on the circle, and it goes through point A, which is the center. And then a chord in this picture is going to be BD. So BD connects 2 points on the circle. CD is also technically a chord, but since it goes through the middle, we're going to call it the diameter. Okay, so the diameter is a type of chord. And then for the radii, the one that we can tell from looking at the picture, the one that you probably noticed first, is AB, because it goes from the center to a point on the circle. So A is the center, and a point on the circle is B. But we also have the 2 radii in the diameter. Okay, AD and AC are also radii. And since those are all radii, that means they're all congruent. So that's what these little marks are here for. They're all the same length. We don't know what that length is for this circle, but we know that they all have to be the same. So since they're all the same, that means that we can prove that this triangle right here, triangle ABD, is isosceles. And we know that's true because AD and AB, 2 side lengths of the triangle, are the same length. And we know they're the same length because all radii of a circle are congruent. And since that triangle has 2 radii for 2 of its sides, that means it has to be an isosceles triangle. So the circle proofs, that would be something that we would write in a circle proof. We're not going to end up doing the circle proofs, so we don't really need the exact wording here, but the idea of this is still important because that's going to help us solve the problems with numbers, because you'll know what things are equal to each other. And also, if you've got an isosceles triangle here, that means that these angles here will be the same. Okay, so you'll see all the patterns with the circles by knowing the rules for circles. So the next thing we're going to talk about is if we didn't have a picture and you had to draw the picture. For this one, it says that we have circle O, which means O is the center of the circle, and A and B are located on the circle. And it's telling us OA is 2x plus 19. So that means OA goes from the center to a point on the circle. So that is the radius. OA is the radius. And you're trying to find the length of AOB. Okay? AOB is 37. And you're trying to find the length of the radius. Sorry. So AOB, that means that A, O, and B are collinear, that they're on the same line. So it goes A, O, and B. Those 3 points are going to line up. And if O is the center of the circle, then that means that that will have to be the diameter. Okay, so it'll look like this. And this is the information they told us. So OA is that amount, that's the radius, and it told us the length of the whole diameter is 37. So you can just do some algebra to figure out what the missing pieces are. So since this is a radius right here, this one is going to be the same, so 2x plus 19. And then you can combine like terms and solve for x, or you can say that the radius times 2 is going to equal the diameter, and you can plug in that way, which is the way I did it here. Okay, but either way, whether you do it by plugging into this formula or just adding all of this together, you'll get this, which means that x will be negative 1 over 4. But the question asks for the length of the radius, so we're going to take x and we're going to plug it into x in our length of the radius, and that will give us 18.5. And if you check your work, make this 18.5 and this radius 18.5, add them together, you get 37, and that means you did it right. Some more vocab words. If we talk about an arc is a section of the circumference of a circle. Okay, so you can have arcs of all different sizes, but what they do is they just connect 2 points on the circle. Okay, so I have 2 points here, and if I connect them, that is an arc. And we're going to measure that in degrees. Okay, so when we talk about arcs, we're going to measure them in degrees for this section. A minor arc is going to be the smaller arc on a circle. Okay, so something that's going to be less than 180 degrees. Okay, 180 degrees would be straight across, and that would be this whole thing. This is less than 180. And then a major arc is going to be the opposite of that. It's going to be the larger arc. So if you look at the two pictures I have here, these are the same two endpoints. The minor arc is the small section that connects the 2 points, and the major arc is the long way around. If you're going to call these something, say this was A and B, this would be AB. Now this one could also be called AB, but we don't really know if we're going the minor arc or major arc way. So most of the time you'll have something else in here, and then you could say it's BMA or AMB. And that little arc on the top means that it's an arc. So that means for this one, you start at B, go past M, go to A. And that's that arc. So that's going to give you a hint as to which way you're going to connect these points to make an arc. And that is shown right here as well. Okay, so if you look at this exercise, we'll talk about the first one. A and D being the endpoints, the minor arc connects them the short way, the major arc connects them the long way around. And you can write that a whole bunch of different ways. Now, arc BCD. BCD is, if you start at B, then you go to C and end at D. So that's this piece here. That arc is going to be half of the circumference. Okay? The circumference is the whole thing. Circumference is the whole circle. It's going to be half of it. And also, we know that a circle is 360 degrees, and this arc has got to be half of that because it's half of the circumference. So this is 180 degrees. And if you notice, it's the arc that's made from the diameter. So whenever you've got the diameter cutting the circle in half, the arc over here is going to be half of 360, which is 180. The last piece we're going to talk about is the part that we're going to use the most. So these are going to help us solve with actual numbers. So a central angle is an angle that's made by two radii. Okay, so if we've got a radius here and a radius here, the central angle is the angle in between them. And I'm calling that theta for this. And the vertex is going to be at the center. Okay, so the center is this point in the middle of the circle. That's where the 2 points are going to meet, and that's where the angle is going to come out of. And the rule for this is that the arc formed by the two radii, so that's this piece right here, is going to be equal to the angle in the middle. So if we were going to make something that looks like this and say that this was 90, that means that the arc here is also 90 degrees. Okay, if we had another example where we had 30, then this arc here is going to be 30 degrees. So that's always going to match if the two lines that we have meet in the center of the circle, if it's two radii. The alternative to this is if you have an inscribed angle. So an inscribed angle is made by two chords. So it's going to meet on a point on the circle. Okay? And the two chords are going to have a common endpoint. That's the point where they touch. Okay? So a non-example of this, one that's not an inscribed angle, is if you had a chord here and a chord here. Those two chords don't touch, so you're not going to get an angle there. But if you had one like this, where they do touch right here, then this is the rule that happens. The angle that we've got here is going to be half of the arc. So the arc is 2 times theta. So for example, if this was 50 inside the inscribed angle, then the arc is going to be 100. Another example of that is if you had, say you had 20 here, then this is 40. And this can work the other way around too. If you know that the arc is, say it's 60, then that means this angle in here is going to be half of that. So that would be 30. Okay, this is the rule. The angle inside is going to be half of the degrees on the arc. So these two rules, we can practice those with this piece. So I would have you guys try this on your own for a little bit. We're going to do a lot of practice with these in the next lesson, but see if you can try it out on your own for a couple minutes to start. Some important pieces of information here is that you should take into account the radii. So AB and BE and BC are all the same length. So that means we've got isosceles triangles in here. So this triangle here is isosceles, and so is this one. So if we were going to look at this, you could tell right away that if this is 65 degrees, then you can figure out this angle and this angle right away, because we know that the three angles in a triangle add up to 180, and these two angles are going to have to be the same because the triangle is isosceles. Okay, so if we did 180 minus 65, we're going to get 115, and then 115 divided by 2 is going to give us 57.5. And then if you wanted to figure out what this angle is right here, well, 65 and that angle are going to make up a straight line. So we know that those two added together are going to equal 180. So we already figured that out right here. That is going to be 115. And you can find these two angles using the same exact process that we did before. you do 180 minus 115 and divide that by 2. So you're going to get 65 divided by 2, which is 32.5. And there's more that you can do with this. Now we're going to try and look at the arcs. So if we were looking at just this 65 for a minute, the 65 is in the angle that comes from, here, let's get rid of some of this stuff. It comes from this angle right here, which is made by 2 radii. So if it's made by 2 radii, that means it is a central angle. It looks like this picture here. So that means that the arc is going to be equal to the angle at the center. So this is the angle at the center, 65. So the arc, CE, is going to be equal to 65. Something else that we know is that if we have the angle right here, DAE, this angle is an inscribed angle. Okay, it's inscribed because it's made by a chord here and a chord here, and it looks like this picture. So that means that the angle is going to be half of the arc. The arc is 100, so that makes the angle in here 50. And then also, it's important to note that the entire circle, all the way around the arcs, are going to add up to 360. So that means half of it, if we cut it in half, this half is 180, and that half is 180. So you can figure out the other 2 missing arcs just by subtracting. So if this whole piece is 180, and this piece is 100, that means this piece over here has got to be 80. And then same idea with the other side. This piece is 65, so this piece has got to be whatever 65 plus something equals 180, which is 115. And we know that we're right because this angle here is 115, and that's a central angle to this arc, which is also 115. So you can figure out every single piece of this picture based on just having that this was 65 and this was 100. Okay? And you can use that same logic for pretty much every example that we're going to do from here on out. Okay, so again, here's all of the answers for that. That's going to be the last example that we're doing for this. I'm not going to have you do the lesson 3 homework because we're going to practice this again in lesson 4. So instead, we're going to do the lesson 4 video, and then you're going to do the lesson 4 homework for today's assignment. As always, let me know if you have any questions. You can message me on Google Classroom or email me or ask me a question during Zoom, and I'll answer your question as best I can, as soon as possible.